Hi, in this video I am going to explain how to apply ratio test and where it is applicable. Let us start with the statement of the ratio test. In positive term series un, if limit n tending to infinity n plus 1th term of series un upon nth term of series un is equal to r, then series converges if r is less than 1, series diverges if r is greater than 1, and test is inconclusive if r is equal to 1. Please note following things. We are using the ratio test for the positive term series. In some books it is written that it is applicable to check the absolute convergence, right? Because when we are checking the absolute convergence, we are taking the absolute value of each term of the series, and series becomes a positive term series. Therefore, it is also applicable to check the absolute convergence of the series. This test can be stated as in positive term series un, if limit n tending to infinity nth term of series un upon n plus 1th term of series un is equal to r, then series is converges if r is greater than 1, series is diverges if r is less than 1, and test is inconclusive if r is equal to 1. Please note most important thing, that which test you are using, because here and here ratio is different and definition of the test is also different. Here series convergence for r is less than 1, here series converges for r is greater than 1. Please note these things. Let us start with the example. Discuss the convergence of the series. Series is n factorial upon n raised to the n. This is nth term, this is n plus 1th term of the series. To get n plus 1 term, replace n by just n plus 1. By definition of the ratio test, r is equal to limit n tending to infinity n plus 1th term of series u upon nth term of series un is equal to limit n tending to infinity. Just this is a simple calculations. Here we express n plus 1 factorial is equal to n factorial into n plus 1, and n plus 1 raised to the n plus 1 is equal to n plus 1 raised to the n into n plus 1. This is the basic rule of the indices, into n raised to the n upon n factorial. Here n factorials and get cancelled, n plus 1 also get cancelled, and we get this, and limit of this is equal to 1 by e, which is less than 1. Therefore, by ratio test, n factorial upon n raised to the n series is convergent. Note, I have applied this first test, not second. Therefore, for r is less than 1, this series is convergent. Take second example. Examine the convergence of the series x upon 1 plus x square upon 1 plus x square, and so on. This series can be written in the form of series n is running from 1 to infinity, x to the n upon 1 plus x to the n. For n is equal to 1 we get this term, for n is equal to 2 we get this term, for n is equal to 3 we get this term, and so on. Here to apply the ratio test, we want nth term of the series and n plus 1th term of the series. So I have written nth term and n plus 1th term. Just put it the value of n is equal to n plus 1 and apply the definition. R is equal to limit n tending to infinity un plus 1 upon un, and substitute just the values of the terms. And this is the simple calculations. Then finally we get the limit r is equal to x. Then by ratio test, this is convergence if x is less than 1, and series is divergence if x is greater than equal to 1, because our limit r is equal to x. Therefore r is totally dependent upon this value of x. Therefore we are defining the convergence depending on x. But what happens if x is equal to 1? If x is equal to 1, then substitute the value of x, which is equal to 1. Then we get 1 by 2 plus 1 by 2 plus 1 by 2. This series is a divergent series. Therefore, this series diverges for x is equal to 1. Thank you for watching this video. If you like this video, please like and share it. For more such videos, subscribe to YouTube channel www.youtube.com/livemathematica. If you have any doubt, write in comment box. Video related to that topic will be uploaded as soon as possible, or you can like the Facebook page Live Mathematica, post your doubts on page. I will try to solve it in couple of days. Thank you.